check this out. In the last episode of the Mantis Blade build, here we go. I didn't like it. What are they doing? The string is stretching since it's slowly lowering. Okay, well, it works, kind of. There were problems, like the string that I was using, rated for 300 pounds, but it was stretching out and falling off of the guides. And those guides were causing more resistance, which compounded the fact that the servos weren't strong enough to move the arms because they needed more leverage. So I fixed all that stuff. A lot of little tiny stuff. Originally, the rear control disc on the servo was the same size as the control disc that was mounted to the front arm that made it move. The good thing about that was it kept this nice and compact so that the whole front end was small. Because the servo turns more than the front needs to, we can make this disc bigger. The servo control disc is 17 millimeters and it turns 270 degrees. The front disc only needs to move almost exactly 144. So with knowing that information, I could work out how big to make the front disc so that I use the entire rotation of the servo to get this to its fully extended position. So with a little bit of math, I built this big old 31.85 millimeter disc to make the front arm move. Leverage issue solved. And because it's so big, I didn't even have to do all the crazy stuff that I did before because I wasn't worried about how big it was. That's already out the window. Because of that, it was easier to make the disc. I could just cut the whole thing out of one piece of thicker aluminum and then grind the groove in it and mount the retainer bolt, but it also caused another problem that it interfered with the arm. So I had to grind the part of the arm frame out so that this would fit in as close as it could to the movement arm. Which brings us to this little gold thing here right next to it. The gold ring is a little chunk of brass that I cut out from a big sheet and turned into this dual roller guide piece that I pressed the bearing into. It's 3 millimeters thick by 7 millimeters diameter. It all started with this big, thick plate of scrap brass that I cut a small piece out of. I drilled holes in that piece and then cut around the holes to get these little pieces that I ground close to shape before mounting them on a bolt and putting that bolt in a drill and then grinding them to perfectly round concentric around the middle. But that was too thick, so I had to thin them down. If they were thin enough, I used a Dremel to very, very carefully grind grooves that were the size of the string into the sides of it. But the size that would fit a bolt was not the size of the bearings because I only have SAE stuff and they're metric. So I had to make a tool. This might not look like much. It's just a little piece of steel rod, but I took my time and very carefully tapered the end down and made sure that this section here was exactly 7 millimeters and then tapered it back off. With this, I heated up those brass parts, dunked them in water to make them soft, and then drove this through it with a hammer to stretch it out to almost exactly 7 millimeters. That way I could press those bearings in and they would stay locked in nearly permanently. But the problem was that brass on that dual roller guide would grind against the carbon fiber. So I needed something to support the inner race of the bearing, which is what I used this brass rod for. I drilled a 3 millimeter hole down through the center of it and then cut off different thicknesses to give me these little spacers that would support those guides and let them spin freely. All of this was because of this part right here. Wait, oh, there it is. This part, that is a tiny stainless steel sleeve that I made to slide on the original string guide bolts that I had on the arm. And it's too small and it was causing too much resistance on the string. We didn't show this in the last video because it's so difficult to film because it's so tiny. But even with those installed, it didn't fix the problem of the string falling out of the roller guides, which is why I built the cable retention and dual roller guide alignment posts. They're just these machine screws right here that I put in to keep the strings from falling out of the grooves. There's a better idea to do this, which is to put spring tension on the wires so that they hold themselves in the grooves, but building a system to do that would have taken a lot longer than putting the screws in next to the pulleys. The first time I used this string, it was stretching out. Every time it tried to move, it got a lot longer, left a bunch of slack, it was falling off the guides. This is static string. It's not dynamic, so it means it's not elastic, and it's also rated at 300 pounds. But if it's not pre-stretched, it will stretch out when it's exposed to a big load. So I tied one end off to a pole in the garage, the other one to a scale that was connected to a ratchet strap to another pole, and then I pulled it tight, put almost 200 pounds of tension on it, and let it sit for a couple hours and kept tightening as it stretched until it became stable. And now it doesn't stretch out anymore and it holds tension. And I don't have a whole bunch of slack forming while I try to use this. With all the bits finished and put on, I just had a couple of clearance issues I had to work out to make sure this thing would actually be able to move the whole way again. But now it works. This is the hardest way for this thing to open because it's fighting the most possible weight and it has no problem with it. Just like it's supposed to. Sideways, other sideways, upside down ways. It doesn't really like it at the front. So, right? Whoa, too much, too much. Go back, go back, go back. The strings came out of the retention screw at the front. See? This is why I don't like this thing. But this brings me to the rest of the issues with this that we found out after we got it all put together. At the front, when it moves the whole way to the front, there's one last clearance issue. The strings get pinched by the arms, so I need to figure out how to make those go around it, which is why it moves really wonky at the front, because it's trying to stop the movement cables from moving it. There's a couple options. Make those clearances, but then in order to get more strength to make sure this thing moves really fast and really consistently, I could upgrade the servos. It's just, they're expensive. And if I upgrade the servos, I should go to high voltage, which means I need new batteries. But then I'm also running out of space on this and I need to figure out where to put the servos and the transmission of power from those servos to the next movement part, which is the part that lets the knife move independent from the movement arms. There's more to figure out, and this is extremely time consuming. And because of that, it's limiting us in being able to get videos out on time. So this is actually going to move to the back burner, kind of. I'm still gonna work on it all the time. We're just not gonna do videos on it until it's done, because we have a whole bunch of other really awesome projects that I really wanna do that I can't because I've been stuck working on this thing. Huge thanks to my patrons for supporting me through this build. You guys are gonna get a whole bunch of awesome stuff from future builds that are coming out really soon. Everybody else, thanks for watching. Want to help out the channel, hit the sub, thumbs up, turn on notifications. Anyway, I'll see you next time. Thanks for watching.